Okay, I think it's my time to start, so I'm going to go ahead and start even though I haven't been told. And if I talk a little extra, well, that's just fine by me. My name's Justin Swanhart. I work at Percona. I also author Flexviews, which is a materialized view solution for MySQL, and Shard Query, which is a sharding scale-out and parallel query solution. So, like I said, I'm Justin, I work for Percona, and let's talk about Flexviews. So, Flexviews is part of Swanhart Tools, and my last name is Swanhart, so it makes sense. I have Flexviews, Shard Query, some utilities like buffer pool, pinning scripts, and BC math UDF. So if you need arbitrary precision math, you can use the BC functions like BC add or BC sub inside MySQL. So Flexviews is a materialized view toolkit. So it's a set of tools. The first is FlexCDC. It's a change data capture utility. I'll talk more about it in a little bit. And the Flexviews SQL API. And the SQL API is a set of stored routines that allow you to define the structure of the materialized views. So what's a materialized view? Well, materialize means to make manifest or to actually store something somewhere, right? So unlike a regular view, a materialized view is stored in a real table, right? So you define a SQL statement, a select statement that is going to return the data, and the data is stored in the view. So it's basically like a cache, right? And these tables or materialized views are available in other database systems. DB2 calls them materialized query tables. Microsoft SQL Server calls them indexed views. Oracle calls them snapshots or materialized views, depending on what version you're using. And Vertica calls them projections. So this is a common database technology that is not actually available in MySQL. Right? Doesn't have native materialized views. The closest thing you really get in MySQL is create table as select. Right? That's going to store the results of a query into a table. But there's no way to go back and update that table when a row changes. Right? So you have a view that is a count star over a billion row table. You add a single row to that table. You have to recount all of those billion rows and one to get the results back. But Flexviews doesn't have that limitation. It has the binary log consumer FlexCDC, so it can automatically update the materialized views. So why would you want to use them? Well, speed is the biggest reason, right? So the results are in a real table, again. So that table can be indexed or partitioned, or you do whatever else you need to do it to get good performance. As a result, you can take complex queries that count star over a billion row and just look in the table to get the count of rows. And so it's basically instant rather than minutes or hours. Right? So it's great for dashboards, caching important result sets, anything that really needs a lot of speed. So it's just a cache, right? Like other caches, like Memcache, the cache gets out of sync when the underlying data changes. So we have to have a way to refresh the materialized view. And the refresh should be as efficient as possible. We don't want to have to rebuild the whole thing each time. Though that is always an option. Right? So you have two options with Flexviews. One is complete, which, as the name implies, it completely rebuilds the table every time. Now, the advantage of the complete refresh is that it supports outer joins. So if you have a view that needs an outer join, you really have to use the complete refresh. Incremental is, as the name implies, incremental. It just applies the changes that have happened since the last time the view was refreshed. Now, it only supports inner joins, but if you're aggregating something like a star schema, you're not going to be doing outer joins anyway. It supports most aggregate functions. The only aggregate function that's not fully supported is group concat. And if there was demand for that, I'm sure I could put it in. It uses the row changes that have been collected since the last time the view was refreshed, right? So it's an incremental refresh. Flexviews is fairly easy to set up. You download Swanhart Tools. You set up FlexCDC. It's a setup script. It's PHP. You need to have a row-based binary log. And if you're on 5.6, you have to have full row images, right? So make sure you don't use the short images. And I recommend read committed transaction isolation level. The reason being is that the tool does use insert select, and insert select has to take gap blocks in order to be. So if we can avoid gap blocks, it's better. So use read committed. Once you set up the Flex CDC and you have it running in the background, you just run MySQL less than setup.sql to run the setup script. It's very simple. So Flex CDC uses the MySQL binlog command to read the binary log from the server. Right? So it's running in the background, and if the server supports it, or the MySQL binlog supports it, it'll just TL the binary log. It'll listen to the server rather than connecting again and again. And it gets inserts, updates, or deletes. It logs the changes into change log tables. Right? So you have to create the materialized view log or a change log on your table. And once you create the log, it's going to automatically fill up with all the changes that are happening to that table. So the natural question that people normally ask is, why not use triggers? Well, first off, they add a lot of overhead, like a lot of overhead. So triggers are not a deal for that. They also can't detect commit order. Right? The binary log is serialized in commit order, which is very important for using it for replication and for updating the views. You can't create triggers inside of stored routines. So I couldn't have a routine called create mvlog that would actually create the trigger on the table, because you can't create triggers in stored routines. And finally, MySQL only allows one trigger per table. So if you want to have different trigger, and that's outside of 5.7 DMR, you can only have one trigger, and that's a big limitation. So it instead reads the binary log externally and updates these tables. So here we have a create table. Let me get my pointer. We have a create table statement, the very simple table, one column. You call Flexviews create mvlog test T1, so we're creating it on the test T1. And then we insert a row into the table, and then we can select from its mvlog, right? So this, when we created the mvlog, a table was populated called mvlogs. It maps test T1 to mvlog 7A52, whatever. Right? That's an MD5 of the table name and schema name. The reason that I do that is the table name can only be 64 characters. So you had a 64-character table and a 64-character schema, it wouldn't be able to create the materialized view log. So it uses an MD5 instead. Now, every materialized view log has 4 columns that start the table: the DML type, the unit of work ID, the server ID, the global sequence number, and then the actual columns from the table. Right? So these things all have a good meaning. Right? Inserts are 1, deletes are -1, updates are -1 followed by a 1. Right? So it's a delete followed by an insert. The unit of work ID is the transaction ID. Right? Unit of work is a DB2 term. The materialized view algorithm comes from DB2. Server ID of the server, and then the global sequence number. Every change gets a new global sequence number. So an update will have an old image of like global sequence number 2 and a new image of global sequence number 3. So that's how Flexviews orders changes within a transaction. I think I'm talking a bit fast. So creating the materialized views, what do? Well, we have to use the stored routines to create the materialized views. Flexviews doesn't have its own built-in SQL parser like shard query does. So instead of you writing a select statement and having parsing the statement, you have to build the statement up with these stored routine calls. It's really simple. They're all documented online. It's my GitHub account. And so you build up the SQL statement to create the view. And they're very easy to understand. It doesn't take a long time to get used to creating these things. Right? So every materialized view has an internal materialized view ID. Right? There's an mview table. That's the primary key of mvID. So every table has a materialized view ID. You create that initial ID using flexviews.create. It takes a bunch of different parameters like the schema name, the name of the table to store the view in, and then the refresh algorithm to use. So that's going to be either complete or incremental. I'll show a complete example at the end. I'm going to do incremental first. So set mvID equals last insert ID. So I definitely use last insert ID. was a question of mine in the proxy SQL talk. So once you have a empty view, you have to add tables to it, right? So Flexviews add table, the materialized view ID, the table that we're adding test T1, and we give it an alias, right? The last parameter is the join clause. So it's an on or a using clause. Since this is the first table, there's no join clause. So you can see here, we have a second example with test T2, alias 2, and then there's the on clause for the join. It supports using as well. So then you have to add expressions to the SQL statement, right? The stuff that's in your select list or in your where clause. So here we first add a group expression, and we're going to group on C1, and we're going to call it alias C1, right? So let's select C1 as C1. And then we add another expression to the materialized view for the count. It's going to do count star, and we're going to call that alias CNT, count. We have everything we need now. We have a from clause, and we have a select clause. We don't need a where clause to build this particular view, so I'm just going to go ahead and enable it. So you call flexviews.enable with the MVID, and that will create the actual table that contains the data for the view. And here you can see we have 2 rows. I inserted a bunch of data into this table in the meantime. We have 2 rows, 1 and 2 primary key, 1 and 10 C1 values, and they each have a little over 1 million rows. I just did an insert select a few times to fill up the table. So that's pretty cool, right? We now have this table that contains the contents of our select statement that we just built. So what happens when the data changes, right? Well, we have to update the materialized view so it's no longer stale, right? So it gets stale or out of date. So we periodically refresh the materialized view. So we use, let's say we insert a new value, value 2. The MV is out of date. We don't see 2 in the materialized view, right? So we have to refresh it. So if we run the real select, we can see that there's that 2 there, right? So we know that it's out of date. So you use flexviews.refresh. You can compute the changes into the delta tables, or you can apply the changes from the delta to the view, or you can do both. The reason why it has a 2-phase calculation like this is you can periodically compute the changes to the view, especially if the table is changing quickly. So like every 5 minutes you can compute changes, but you can update it once an hour or once a day. And you can update the last parameter to refresh, which I'll show you is normally null, but you can use a transaction ID to update multiple views to the same transactional point in time. So you can have a bunch of different materialized views that are all in sync with each other. Right, so I call flexviews refresh, give it the MVID, compute, and tell all the latest changes. Null is just all the latest changes. And we now get a row in the materialized view delta table, right? So it's an insert into the materialized view with the count, or C1 being 2 and the count being 1, right? And you can see I inserted a whole bunch of rows, those millions of rows. So my GSN has gone up a lot while my transaction ID is not. Then you apply the delta. So once again, refresh the MVID, but I say apply. And then null to apply all the latest changes. And then when I select from the materialized view itself, you can now see the row has appeared. Right? So the materialized view has been refreshed with the changes. Complete views, right? You can work on views that have outer joins or use group concat or whatever. Basically, it just uses create table select and rename table to manage the view. So here we create a demo top customers complete. We call Flexviews set definition. Flexviews get ID will get a materialized view ID if you don't know what it is. So we're going to update we're going to get demo dashboard top customers. And then that should just say top customers. And then the select statement that actually represents what the view will contain. And this one has a order by. So the results in the table will be in the order of the order by, which is convenient because there's a primary key on the table, so it's kind of an automatic ranking if you want to rank stuff. And you just Flexviews enable, again, get ID, and that will just build the view. So FlexCDC is also pluggable. If you want to replicate to Redis or to PostgreSQL or to some other system, or you want to populate a message queue, or you want to invalidate memcache, you can use FlexCDC to do this. Right? So it's a PHP script, it has a PHP interface that you can code a plugin around. So the plugins get insert, update, and delete information as, in addition to when a transaction starts and ends and a few other things. So you can do all kinds of cool stuff like write to a message queue. It's probably too small to read, but it's a require once plugin interface, class FlexCDC plugin, implements FlexCDC plugin interface, and then we have a begin transaction, insert, delete, update before and update after. Right? So you can put whatever behavior you want into those functions and do pretty much anything you want to do with your binary log data. Right? Everybody else has been mentioning the binary log. It's awesome. It does all kinds of cool stuff. And then there's a quick reference, create, get, add, expression, right? So really it's pretty simple. And fast and efficient. And that's it. Any questions?
That's very impressive. I think in other databases you could have serialized view to continually refresh in real time. Your one is like you can set the refresh rate every day.
Right. Yeah, it's still asynchronous. I don't have a refresh on commit. It's because MySQL doesn't have commit triggers. So I got to get the data out of the binary log, so it has to be asynchronous. Thank you. It's about 8 years old at this point, and it's being used in production by a number of companies. So it's a stable tool.
So the update of the view cannot be really automated using just MySQL code, right?
What's that?
You have to manually execute the refresh somehow.
Right. You got to call.
Also to do it only through.
You can use a MySQL event, right? So it actually comes with two different events that will refresh and compute views on a schedule. So like every minute you could refresh with using an event.
Next question is about replication.
Mm-hmm.
How the result of the code with Flexviews, how they are replicated.
Stored procedures are just replicated as calls themselves. So as long as you have the stored procedure code on the slave, when you do the updates on the master, they'll automatically replicate down. The only time Flexviews sets SQL log bin equals 0 is when it's inserting data into the log tables themselves, because it would create a loop. No problem. Any other questions? Well, thank you.